didn't either, because I was gone all last week.
Okay.
Except for Monday.
Alright, practice guide here. Over chapter 4, chapter 8, did anyone not receive one? Let's start there first.
Well, I don't have a weekend. Can I have one?
Maybe me.
Probably.
Okay. There you go. Okay, we started this last, I think, Thursday. We're ready to go. Technically, I have it, the test set for tomorrow. We'll see how far we get today on this, because we only have 20 minutes. So we're pretty
I
much
still
going to
take
make sure.
it Thursday.
So.
I thought we were supposed to take it Friday.
Oh, I did.
I have no lead.
Okay. Anyone else not receiving? Okay. All right. Vocab here, we did this on Friday last week. This is when we started reviewing. Vocab, remember, I went through each, what each of these were, kind of pointing coughed at which words they were. We went through all the definitions of the words that were on that list. Some of the words that I have clearly skipped over would be like equilateral, triangle, right triangle, obtuse, acute, right angles. Let's see. Let's see. Equiangular. We skipped over any of the SOHCAHTOA stuff like sine, cosine, tangent. Those are free game. Pythagorean Theorem. Hypotenuse, leg. I think leg's on there, but hypotenuse is a word that I didn't have on here. So keep that in mind. Those are words that I skipped over that you might want to go over. Remember, this over chapter 4 and the beginning of chapter 8. I have the sections written here, plus on the website they kind of tell you what sections we went over. The ones I'm really worried about are these postulates that were in section 4.3 and 4.4. Those are the ones I'm actually worried about because the words are so similar. So keep those in mind. You might want to study those. We did one of these on Friday, so if you want to go back and look, it's basically figuring out like what this letter corresponds to on the other picture, comparing one picture to the other if they're the same. So keep that in mind. Knowing how to write your answers down, especially if they have symbols and little letters, or if they want numbers, that's something we talked about Friday. You should definitely watch that video. I made sure it was on the line this morning. I double checked it to make sure it's working. I think I just had to attach it to the website, but it was on YouTube, I think. Alright, these three were ones that we talked about Friday as well, where you had to tell me, are the triangles equal, on the one picture. It's a yes-no question per picture. And then you had to tell me, what was the reason if it was yes. And I had the reasons up here, SSS, SAS, or ASA, and on the test there'll be a fourth one, AAS. Those are the only 4 you can use. We did a proof on Friday. This was, I think, 5 steps, because you had to go 1 extra step. I would definitely expect a proof to be on the test. 3, 4, or 5 lines, somewhere in that range. I don't know necessarily if I'm going to go with the statement of reasons, or I might go flowchart, but if whatever form I pick, you have to give me enough reasons to give you full credit for it, so keep that in mind. This one we ended with on Friday. We had to find the value of x. The thing I warned you on this one, you'll definitely need to show work, and make sure that you're common sensing it when you start. Like, is it isosceles? Is it equilateral? Is it scalene? Do you have enough information to figure it out? And not doing the silly mistake that people make when they look at that picture where they try to add all 3 walls to equal 180. That's stupid. That's not how that works. Okay, so you have to set certain walls equal to each other. Okay, so that was your hint. Okay, the one on the test, it could be find multiple letters, so just be careful of that. There'll be something from the chapter that I picked that we've had in the homework. Okay, all right. We're going to start here today, and wherever we finish, we finish, and then we'll pick up tomorrow. If we get all the way done, fine and dandy. If we don't, fine, we'll continue tomorrow, because I know tomorrow's a short period anyway. So, yeah, let's get started. If you need to go grab a calculator, this would be the time to do it. You will need a calculator. The thing I warned you on Friday, I only have 10. There's more than 10 of you in here. Okay, so keep that in mind. There should be. Did somebody already borrow one today? Hopefully somebody already did. There should be 10 back there when you first walked in, I think. But anyways, you need a calculator for the test, and you need to know how to use it. So, like on these questions, when we start getting into the square root stuff, when we start getting into SOHCAHTOA, a question on the test I don't answer is, Ward, how do I type this in? What does this answer mean? I don't answer those on test day. Like, you need to know how to use your calculator or mine, and I don't answer those types of questions. So keep that in mind. And you can get mad at me all you want, it's not my problem. Okay, you got to figure it out, you got to ask questions today if you have any, or today after school, or tomorrow morning. Okay, so keep that in mind. Let's start with this first one. What you have to do on this first one is you have to simplify it. Not just give me the decimal that your calculator gives you. If you just wrote down the decimal, you didn't read the instructions. It says simplest radical form, not a decimal. So simple radical form is where you break these down into two numbers that multiply to give you 72, and you go as far as you can. And I always go in pairs. And then once you're at the very bottom, then you look at your index number and see if you need to circle pairs or triplets and kick some out. That's what we have to do here. So 72, like when I think of 72, I think of like 8 times 9. I know some people might think differently. That maybe they think of like 6 and 12, or 36 and 2, or what are some other ones you could pick? But anyways, but I went 8 and 9. Then you break those down even further. 8 is 4 times 2, and 9 is 3 times 3. And then you can break down 4 even further. 2 times 2, and 3 times 3. All right, so these are all the numbers that are in 72, right? I broke them down one at a time. I didn't lose track of any of the numbers. So when I broke down 4, I still have the 2 and the 2 3s here. So I have all the numbers accounted for. I didn't lose track of any of them. And what's my index number on the outside?
2.
Yeah, there's a 2 here. If it's not printed, it's a 2. If there's a 3, fine and dandy. If it's 4, they have to have those printed. And what you're looking for in this case, we're looking for pairs. That's what this little index number means. We're looking for two numbers that match. Well, we have a pair of 2s and we have a pair of 3s. And again, you can rearrange if you need to put them all next to each other. That doesn't matter. But we do have pairs, and what are we supposed to do with the pairs?
Cross one out, give one.
Yep. Cross them out, kick one out. Cross them out, kick them out. That's how it works for triples or quadruples, whatever you're going to be doing. You cross them out, you kick one of them out. That's how it always works. So it looks like the 2 and 3 are on the outside, and those will be multiplied together because we don't suddenly change the operation, it's always multiplying. And then the thing that's left on the inside is just a 2. So you'll have to go, one more step to figure out your answer, but that's your final answer. That's how you're supposed to attempt that problem. Questions on what I'm going to ask you to do there. It'll be some number, you can break down as far as you can. If there's certain pairs, fine. If there's no pairs, you can't do anything with it. You just leave it alone. You go back to the original number. But I did have a couple pairs and I kicked them out. And again, what does this make on the outside? 6. So 6 root 2, that's your answer. Okay, questions on how to simplify radicals. We spent a lot of time on that. I think we spent 3 or 4 days doing radicals. So go back and you can check those out. That was the beginning of, what was that? The beginning of chapter 8. Maybe you're starting to do that. Simplify radicals and whatnot. Okay, questions. Perfect, moving on. Next one. This next one talks about legs and altitudes. This is a huge right triangle. It's big. It's got a big right angle in there, and there's an altitude dropping down. So this is the altitude. And these are the legs. I don't care which one you call leg 1 and leg 2, but there's 2 different ones. So leg 1 and leg 2, I don't really care. Okay. You have to use the leg altitude formula. Those formulas are on the board. They're right over there. You can see them. Okay. They'll be there on test day, so you know how to use them. I will not tell you how to use them or which part's which. I don't answer those types of questions. So if you're looking at the board, you can kind of tell. Usually when I start these problems, I usually go after the altitude first. I don't know why, it's just a little habit of mine. That's the one I go after first. So how do you do the altitude? The altitude formula, if you can't read it over there, because it's really dark in here, you put the altitude here and here. That's your altitude, right? You put it diagonal from each other, the same number. So in our case, it's x's. You can put x and x. And then the parts at the bottom are these 2. And those are the parts that you put here and here. Okay? Those are the parts of the hypotenuse. This whole bottom is the hypotenuse. So you put the 2 parts. But again, the altitude is the x. So that's how you start part 1, and that's how I want to find x. Once I find x, then we'll go after y and z. And those have their own formula. It's the leg formula. But let's do x first. So when we have this, notice we have 2 x's here, so you're going to have to cross, multiply, set them equal to each other. So I'm going to multiply these 2 together to get x squared. X times x is x squared. 9 times 7 is what? 63. Then the last step is to take the square root. That's how you get rid of that little power of 2. You take the square root to the other side. So that's the answer for x. So we're done. We'll move on to the next part. And that's all you have to put. That's the answer for x. That's how tall it is. If you want to type it in your calculator, fine. The square root of 63 is almost 8. It's 7.9. Okay, on the calculator. How I know that? The square root of 64 is 8. So it's close to 8. It's just barely short of it. Well, let's find one of the other letters. So let's go after y now. Okay, y is a leg. So now we have to do the leg formula to find y. How the leg formula works, you put the leg diagonal from each other, leg and leg. You put the part closest to the leg, if we're going to find y, this is the leg we're going to be finding, the part closest to it is the 9. That's the part closest to it. And then the whole bottom, what's the whole bottom?
16.
16. That's how the leg formula works. It's always the whole hypotenuse, the part closest to the leg, and the full leg. And again, this is the full hypotenuse. And how we got the 16, you have to add the 9 and 7 together. Duh. That's how you get the full bottom. That's where we get the 16 from. And then you do the same math. You cross multiply. In this case, my leg is the y. That's the letter I'm using. That's the one I'm trying to find right now. So I've got y and y, so that's y squared. I'll take 9 times 16. What is that? 144. I'll take the square root of it. Is that right? Is that 9 times 16? Okay. And then take the square root of that, which actually turns out to be 12. It's actually a nice number. That's the length of y. Nice. And then you go after z. What would the formula for z be, since it's a leg? So maybe walk me through what would the formula look like. Since we're going to go after z now, and that's a leg, where do I put the z's at? Just like the last one.
Bottom left and top right.
Bottom left, top right, okay, z and z, that's a leg. Then what else? What else am I going to use?
7.
7, part closest to it. And the whole bottom?
16.
16. And then you can just solve that one. That's how you do the leg. Again, the formulas are on the board, they're over there, they'll stay there. I even have the picture drawn with it all labeled. It'll be right there for test day. I might make it a little bit darker for the picture. Okay, questions on how to find that. And yes, you have to find all 3 parts. That problem, I think, is worth 9 points. Don't skip it on test day. 9 points. If you only find 1 letter, if you only go after 1, you just miss 6 points because you missed the other 2. There's 3 letters there. That'll be one of the problems I pull out of the book. And it can be decimals, like the square root of 63 is a decimal, it's fine. I just leave the square roots if it's easy. Like z, I know it's going to be a weird decimal, but you can leave it a square root. Okay, questions? Perfect. Okay. Again, that was, I think, the beginning of chapter 8. I think it was the first section of chapter 8, and I pulled problem or 2 from there. All right, let's move on. All right. So now the next ones go off of what these were, the legs and the altitudes here. The next 2 problems are based on the Pythagorean Theorem. So a squared plus b squared equals c squared. The Pythagorean Theorem, it's on the board, it's over there, it's right in the middle of the board over there. But you have to be able to look at the picture and know which one's a, b, and c. So again, use the Pythagorean Theorem, this is the Pythagorean Theorem, a squared plus b squared equals c squared. It'll be on the board on test day. But the problem is, you got to know which one's A, B, and C on your picture. So up here we have the 12, 5, and the X. Which one's A, and which one's B, which one's C?
C is X.
C is X. Okay, I agree with that. Why do you know that?
Because, well, when you add the 2 legs, it equals the hypotenuse.
Okay, and yeah, X is the hypotenuse. It's the big wall. It's the one wall that doesn't touch the 90-degree marker. So this has to be C. Okay, the legs are the ones you add together to make the hypotenuse. So that is the hypotenuse, and then these would be A and B. I don't even care which one's A and which one's B. A could be the 5, B could be the 12, it doesn't matter. But again, you square them. 12 squared plus 5 squared equals X squared. That's your hypotenuse squared. You'll get these numbers, whatever these are. It turns out a really big number. That's like a 144, it's 125, or that's a 25. This makes 169. And then, to solve for X, how do I get rid of the whole power of 2? Square root. And that turns out to be a pretty number. Now, if it doesn't work out to be a pretty number in your test, fine, leave it a square root, you're fine. You can write the decimal down, but you do have to show the work. This is the type of stuff I should see on your paper on test day. Because if you don't show me that, I just figure you copied the person next to you and you missed the 4 points leading up to your final answer. That you're not showing me how you're setting it up, what the letters are, what you're doing. Because I'm not going to promise you that it'll work out to be a nice pretty number like that one is. Okay, so You shouldn't be able to just go, oh, I just know it's this. Yeah, you wouldn't know that without doing the formula. So, be careful of that. Okay, questions on how to find, whatever x it is. Now, be careful, the hypotenuse is not always the wall that's missing. That's something like, I don't know why I have to tell you this, but, whatever the picture is, what if this is the wall that's missing? And this is a 4, and this is a 5. Then, this is A, this is B, and this is C. You're not always missing the hypotenuse wall. The wall that's by itself is not always this wall. The wall it's missing. Because on this picture, these are the legs. So you'd have to go x squared plus 4 squared equals the 5 squared. Okay, so because the x is on is one of the legs, so that's the two you have to add together. So now this is 16. That's a 25 over here. This is x squared. And to solve, you have to subtract the 16 across and then take the square root. Okay, so keep that in mind. I don't know why, some people just need to see that, they can't adjust this in their head. They have to see a picture of it. But just remember, the hypotenuse is not always the wall you're trying to find. All right, questions, comments about Pythagorean Theorem? Perfect. Okay, now let's talk about this question down here. Okay, this bottom question. It uses the same formula. It's going to use the Pythagorean Theorem. This question is 2 stages, 2-part question on number, what is this? This last question on this 3rd page here. Okay, this question is whether you have a triangle or not. It's whether it's a triangle or not, and if it is, what type is it? Okay, so when I first start this problem, the thing you should check is this even a triangle? So whatever 2 walls you pick out of the 3 here, I'll just pick the 2 smaller walls. When you add them, they should always be more than the 3rd wall. They should always. If it's not, let's say that this 3rd wall was 20. Well, these don't add up to be more than the 3rd wall. So then that would not be a triangle. But in this case, they use 13. This does work because this adds up to be 18. And that is definitely more than 13. Or if you add the other 2 walls, like I've added these 2, that is definitely more than the 9. Or if I add these 2, that's definitely more than the 9. So you have to add up 2 walls. They should always be more than the 3rd wall. So yes, this is a triangle. So I'm going to put these numbers on my triangle. So 9, 9, and 13. 13 is the big wall. Okay. Since it is a triangle, I would attempt to do the Pythagorean Theorem. So I would square these. So 9 squared plus 9 squared. And I want to see, is this in fact equal to 13 squared? That's what I want to check. So 9 squared was at 81. 81. And this turns out to be a 169. If I add these together, that's a 162. So definitely not equal. Agreed? They're not equal. So it's definitely not a right triangle. If they're equal, then it would be a right triangle, like when you do the Pythagorean Theorem. But again, I would not be doing this math if my first test that I did earlier, where add 2 walls, they should always be bigger than the 3rd wall. I would not be doing this check unless I knew it was a triangle in the first place. Because one of the questions I got the last couple days in here was what if this is your problem? That's not a triangle. Because when you add 2 walls, they're not bigger than the 3rd wall. It's actually equal, so that is not a triangle. But when you do the Pythagorean Theorem, that's how I can check for right triangles. Okay? Because Pythagorean Theorem, if it's equal, then it's a right triangle. But you have to square the walls. Okay, in this case, definitely not a right triangle, but now we have to check what type it is. Now, what I always do is the hypotenuse tells me everything. If the hypotenuse is too big, it's obtuse. If it's too small, it's acute. If it's perfect, it's a right triangle. We already threw out it's not a right triangle. It's not perfect. They're not perfectly equal. Is the hypotenuse too big? Then this is obtuse. This is an obtuse triangle. The reason why, this wall turned out to be too big compared to the other, so that means this angle is too big. It's not a right angle, it's huge. It's obtuse. It's past 90. Because the bigger the hypotenuse wall, the bigger the angle gets. That's how it works. So it's definitely not acute. It turned out to be obtuse. But again, you'd have to check if it's a triangle in the first place. Because if it's not a triangle, you put not a triangle and you move on to the next round. You don't even have to do this check. Okay, questions? Okay, I think we're going to stop there today. I know it seems weird. We'll continue on with the review tomorrow. The reason why, we still have the back page. And the back page requires a scientific calculator. We have to do SOHCAHTOA for the back page, and I think that's a good stopping point. So tomorrow we'll continue review, and then Thursday we'll take the test, okay? What happened to the back of yours?
I have no backside.
Weird. Yeah, over there. Alright, we'll stop there today. We'll continue on. Now, if you actually watched today's video and stuff, that's fine. But we're going to continue on tomorrow, so keep that in mind. So.